Hey, welcome back. We're going to be solving inequalities by addition and subtraction today. In the past, you have solved equations, the things with equal signs, by using additions and subtractions. So now we want to solve inequalities using addition, and we want to solve inequalities by using subtraction. So those are our two goals or objectives for today. The first thing, I guess, is what is an inequality? And so that we know inequalities have signs greater than, less than, but they also have signs like greater than or equal to, less than or equal to. Anything with those symbols are an inequality. So if you remember, when we had equations like x plus 12 equals 8, we just subtracted the 12 to the other side so that these 12s canceled out, and I had x equal to -4. Now, the difference will be that I have, instead of an equal sign, an inequality sign. So let's say it's x plus 12 greater than or equal to 8. I'm still going to do the same steps. I'm going to subtract 12 off both sides. These will cancel out. I'll be left with x greater than or equal to -4. Okay? So try these two on your own. The first one will be 22 is greater than m minus 8. In the second example, I'll do d minus 14 greater than or equal to -19. So in the first one, I can add 8 to both sides. So I get 30 greater than m. And my second one, I add 14 to both sides. Those cancel, and I get d greater than or equal to -5. So when I add something to both sides, that's solving by using addition. But in that first example I gave you, I subtracted things off both sides, and that's solving by using subtraction. So I'll give you a couple more that are solving by using subtraction so that we are really confident in our abilities. Our first example is m plus 19 greater than 56. And our second will be p plus 8 less than or equal to 18. So go ahead and try those out. Here I subtract 19 off both sides. M is greater than 37. Here I subtract 8 off both sides. P is less than or equal to 10. Okay? Now, the way we write inequalities in algebra is different than we're used to writing them regularly. Last year, you were able to write them like this. In algebra, we use something called set builder notation. And it's called set builder notation because we're going to build the set of numbers that m can be. So we know m is all the numbers greater than 37. So the way we would write that is we use these fancy brackets because we have fancy people, and we say m such that m is greater than 37. More fancy brackets. It's not really super different, and it's not hard. So we have our fancy brackets, and we have whatever variable it is, m. This line means such that. Okay, and then we go ahead and write that inequality that we just solved. But we do want to go ahead and put our answers in set builder notation. So go ahead and take this problem that we did, and let's move that into set builder notation. Okay, so you should have P such that P is less than or equal to 10. And if you don't know how to make this cool up and down line on your keyboards, I believe you use Shift and then the key that's right above the Enter. It has like a line and a slash like this, and it may look like a broken line. It does on my computer, but it'll look like a key that looks like this, okay? And that'll give you the such that line. The last thing we want to talk about is variables on each side of the equation. So let's say I have 3a plus 6 less than or equal to 4a. Well, subtracting the 6 to the other side may not be super advantageous because I'm still going to have variables on both sides. What would be more advantageous would be to subtract the 3a off of both sides. These will cancel out. I'll have 6 greater than or equal to a. If I want to write that in set builder notation, go ahead and see if we can practice that. You should get a such that a is greater than or equal to 6. Notice that when I put the variable on the left side, the sign flips. So if your variable is on the right and we want to put it on the left, you need to flip the sign. So this is what my set builder notation would look like. Also, if I want to graph this solution, this should be something we remember how to do. I'm going to put some numbers on a number line. And if it's greater than or equal to or less than or equal to, remember I have a closed circle. If it's greater than or less than, I just have an open circle. So for this problem, a such that a is greater than or equal to 6, am I going to use a closed circle or an open circle? Good, a closed circle. Closed circle on the 6, and then a is greater than 6, so my arrow points this ways. Okay? So go ahead and try one of these problems on your own. We'll do 9n minus 1 less than 10n. Okay? And when you give your answer in set builder notation, and then tell me if you were graphing, if you would use a open circle or a closed circle. So if I move my 9n, to both sides, I have minus 1 less than n. So my set builder notation, fancy parentheses, n such that n is greater than negative 1, close fancy parentheses. If I were to graph that on a number line, I would put an open circle on negative 1, and my arrow would point to the right. Thanks for watching.